It's growing very, very quickly. And at the moment we're 15 people in our SRE team, which is the system administrators for the production environment. That's the team I'm working in. So I've been working at Spotify for around 1 year. I'm responsible for the Puppet setup in there, and also our playlist system and Cassandra systems that we use for a lot of the databases and backends to our backend systems. There's also a couple of people here that are administrating our testing environments. So if you want to hear about that, there's one of them talking this afternoon at the Build a Cloud Day. You can hear a bit about how we use Cloud Stack. And so on. And I'm also a community contributor to Puppet, contributed a couple of patches and so on. Some of them that I've done in my spare time and some that I've done at Spotify. So let's talk a bit about our Puppet infrastructure and so on. At the moment we're managing roughly 3,500 nodes using Puppet. It's spread out into 3 different setups of Puppet. So there's one Puppet master and setup that handles all the desktops and laptops that are mixed Linux, Mac OS and Windows systems, but they're all being set up using Puppet as well. It's not a terribly complicated setup of Puppet, but there's a bunch of stuff like distributing SSL certificates and stuff for logging into the networks and making sure they have disk encryption running and all that sort of stuff that you can also use Puppet to manage, not just servers. But then we also have 2 different Puppet setups for all the servers. So there's one setup for the testing environment, virtual machines mostly. And then there's one Puppet setup for the production environment. And those 2, the testing environment and the production environment, they share the same code base, so it's the same manifests and modules and everything like that. But for the laptops and desktop, it's an entirely separate code base, because there's a few things that might be shared maybe, but it's very little. But for the testing environment and production environment, it's separate certificate authorities in Puppet, and there's separate Puppet DB servers. We've been using Puppet DB since it was released, basically, the 0.9 release. And at the moment we have 3 different Puppet DBs running in production, and it's been working great so far. So if you're not running that yet, I can recommend it. And yeah, in the production setup, it's one Puppet master per data center. So the one that's handling the most traffic at the moment is handling around 1,000 nodes. And they all have a runtime of every half an hour, the default runtime. And it's roughly 2,000 managed resources per host. So the heaviest loaded Puppet master at the moment is managing roughly 1,000 resources per second, which is quite a bit, but it's fairly sizable machines as well. It's a 24-core server, so I guess it's pretty beefy. We've been using Puppet since 2.5 years back. So it was like the end of the 0.25 and then 2.6. It was a bit mixed in the beginning. There was like Debian Lenny machines and Debian Sarge, was it before Lenny? Can't remember. But yeah, we're using Debian on all the hosts, so they're fairly, they look alike a lot. But also what's kind of interesting is that we actually do a lot of changes, and like we use Puppet to empower the developers to do changes to our production environments, and they participate a lot in the work. Without that, we would have to be a lot more system administrators, I think. So it's great that Puppet allows us to do that. So there's over 137 different people that have committed code into our Puppet repository at the moment. And there's more than 300 changes every month going on. And as I said, they have a runtime of 30 minutes. So when you push in one of these 300 changes, within 30 minutes it's out in production. Because as we don't have any like maintenance downtimes, we're up 24/7, or we hope to be up 24/7 at least. So there's no like good time usually to take down systems, to do maintenance or anything like that. So we just ship it out immediately. And there's 240 different Puppet modules in that repository. So there's generally one for every backend system that we have, and then a lot of shared modules between the different backend systems, like Cassandra, as I mentioned, or other databases and web servers and stuff like that. And then we're using Gerrit for code review at the moment. So developers can commit code and develop code for Puppet, but before it goes into the production branch, it's reviewed by the operations team. And to do that, we have a script so that a Git branch is a Puppet environment. So developers can push changes to any non-production Git branch, and then we have like a small wrapper script around Puppet. So you can run Puppet and say like, I want to run it on this Git branch, and then it will run. They can test the changes on some dev machine, or on dev machines they can permanently switch the machine to run on a separate on another Git branch or Puppet environment, and test out their changes. When they're happy with them, they send them to Gerrit for code review, as I mentioned earlier. And I think that's a great system. It scales pretty well with more people and so on, and also allows you to test the code on any machine you want. It's not like fixed branches that are for testing or production or anything like that. You can make feature branches and test on one of the production machines if you want. And then at the moment, for node classification, it's a bit of a mess, to be honest, at the moment. We're using different external node classifiers in every Puppet installation that we have at the moment, which isn't that great system. So we're using Foreman, we're using Puppet Dashboard, we have our own external node classifier that we've developed, which is basically our server inventory system that also functions as a Puppet node classifier. So to do something about that, we're planning on switching to Hiera fairly soon to classify nodes instead. Yeah, maybe no, but you can then you can do an array lookup in Hiera, which would basically look in every level in your hierarchy and merge the results into an array. So you look up, say, the classes key, and it looks that up in every hierarchy level and merges the results, and then you can just include those classes that you get out from that. So to do that, we have a new hosting standard that we're using for that. Actually, up until quite recently, we had female names on all our servers. That sort of works for possibly 100 servers. We kept doing it until we had almost 2,000 servers. If you're doing that sort of stuff and planning to grow quickly, I can recommend you to switch to some other hostname standard a bit sooner than that. But yeah, we started having pretty strange names on the servers. So we ran out of all the common names. And they all sounded very alike. So what we're doing now instead is that we're having a hostname standard that is it contains which site they're in. So this host in this example is in the Stockholm site, the first Stockholm site. Sometimes we have several sites at the same location. And then it's the service it has, and then which pool of that service. Sometimes you might want several pools of the same service, and then just the ID in that pool. And these are all available as facts that we can use in the Puppet manifests, but we also use them then in the hierarchy. So then instead of setting in, manually putting hosts into groups or tagging Puppet classes on individual hosts, we can instead set Puppet classes at the service level in the hierarchy. And that allows us to easily scale up a service, to have the same Puppet classes on all the nodes in a specific service, and so on. So it's a pretty scalable system that seems to work well. But nothing super fancy. It's not hard to do. So, and then earlier on we could use, in all these previous external node classifiers that we've used, we've been able to query them for both what classes should this machine have, but also been able to do the kind of reverse query, like what machines have this class. And that's a little bit trickier to do with Hiera. You can't, because Hiera doesn't have any list of all the hosts. And for example, as I said, we're running PuppetDB, so that actually has a list of all the hosts. But to get which hosts have a specific class, it's or should have a specific class, then you'd have to look up the facts for every host and then do a Hiera lookup for each one of them and then check which ones matched. So, and that's a little bit slow, at least at the moment with Puppet 1.0, because you can only look up the facts for one node at a time. So that results in thousands of PuppetDB queries. That's getting a lot better now with Puppet 1.1, because you can put facts for several nodes at a time with the new PuppetDB query language. But you can also query PuppetDB for which nodes have a fact or have a specific class. So then you get all the classes that have been included by other classes as well. But that also works. So we've started using PuppetDB more and more to query for facts like that, or facts as in what classes machines have and so on. But that tells us a bit about, what they're configured to do, but that's also sometimes a different story than what they're actually doing. So we're using SRV records for service discovery. So all of our backend systems, when they want to find each other, they're using regular SRV DNS records to find other services or the other servers that they need to contact. So from PuppetDB we can query and say what nodes are configured to do this, but then we need to look at the the SRV records to say like which nodes are actually taking live traffic, actually taking traffic. And we're planning on switching to using SRV records for Puppet as well, but that's when we switch to Puppet 3.1, because there are some bugs around that in Puppet 3. So we'll do that soon. So to look up like what nodes are serving what service and so on, we have another tool that we've created called WASD. I'm not sure what the letters are for. It used to be called WhoAre, but yeah, but especially with the French guy that created the tool, it sounded kind of nasty when he pronounced it. So I think that was his intention when he named it as well. That one ingests all these SRV records. It has like discovery plugins for different service discovery mechanisms. So it has like for DNS, so you can check the SRV records, CNAMEs, A records, all that stuff, but also for Cassandra rings, so you can connect to a Cassandra server and check what other hosts are in the same cluster. And then ingests it all into a Cassandra cluster, so we can, and that tool can be used to ask like, what is this server actually doing? Like, what services is it serving traffic for? You can ask it like, which servers are serving this service for this site, and all that sort of stuff. And it's open sourced on GitHub, has a REST API, and patches are welcome. So it's not a specific Puppet tool, but it can be useful to also answer that side of the service discovery part. Any questions? Yeah.
What do you use Puppet DB for in
Yeah, the question was what we use Puppet DB for and Hyera. So, as I mentioned earlier, or maybe I didn't mention, I don't know, we're using Puppet 3 at the moment, at least. So, which has the data bindings feature, which when you include a parameterized class, it automatically checks in Hyera to look up the values for the parameters. So apart from tagging the classes of a node, that we're looking up the parameters is something we use Hyera for a lot. So we can say that, I mean, for a lot of our services, for example, we want different parameters in the production environment and the testing environment. Mainly because the testing machines have, or sometimes because it's like they have different servers and so on. Sometimes it's because the testing machines have a lot less memory. They're virtual machines with only a few gigabytes of memory and so on. So we need we can't use 20 gigabytes of cache for databases and that sort of stuff on the virtual machines. So we use Hyera to differentiate and set those parameters, and we're using that more and more. It's gotten a lot easier with Puppet 3. Then with Puppet DB, I mean, we're using it for exported resources. That before Puppet DB came along, we didn't use exported resources at all. We didn't have the old store configs, mainly because, I mean, it didn't really scale for our size. So we're not like a really heavy user of exported resources. We've started using them more and more, and they're so that one node can define a resource and then it can be collected on another resource. So we're using it for some stuff like distributing SSH keys for example, the the Gerrit replication to the Puppet masters is configured using exported resources, so that Gerrit exports its public SSH key, and it's collected by the Puppet masters, and they put it in their repository replication directory, and then Gerrit can SSH in and replicate all the git changes. But we're also using PuppetDB for various queries and so on. We've created this PuppetDB query module that you can use to query PuppetDB from inside Puppet manifests. So you can query it for all sorts of stuff. I mean, sometimes you might not want to use exported resources. Maybe you just want a list of IP addresses in some template file, and then you can, like, for example, if you have a load balancer and it wants to find out what web servers are behind me that I should load balance to, then you can do a PuppetDB query to, for example, to search for hosts that have the Apache class and that are in some specific site, and fetch the IP address for all of these hosts. And then you can just use that array of IP addresses and put in your template file. So that's something we use PuppetDB for, as well as exported resources. And some various miscellaneous tools, like as PuppetDB stores the facts for all of your machines when you're using it. We've created a small tool to do higher lookups for some other machines with a REST API. So for when we're specifying the classes that the machine should have, at least we can do it like the forward lookup. If I have a specific host, I can find out what classes it should have from using the facts that we pull from PuppetDB and then querying the data in Hiera. But I guess there's probably more tools and uses for PuppetDB to come. We haven't upgraded to PuppetDB 1.1 yet, but that one has a brand new query API that allows a lot more complex queries, and you can probably create some nifty tools around that. Any other questions? No? I guess we'll have lunch.
Okay, so we're going to break for lunch. We're coming back at